and this is where I teach. Riverside School, and as you see, it's a school beside a river. It has its benefits, but it also has its drawbacks, as those of you who read the news about what the weather's been like in the Czech Republic in the last couple of months has been. Okay, I'm a Google certified teacher, and some of you may have noticed that in the pre-conference publicity material, they showed one of my application videos that I did for becoming a GCT, and again, it was done entirely in Scratch, and it was unsuccessful. The next time I did get in, I'll say more about that later. Also, another one, U4Energy, was an EU-sponsored challenge for schools and school children to build in energy awareness into the curriculum. And one of the things that many sessions we've heard recently is context is important. And I use energy awareness as a context for a lot of my curriculum. And you'll see why later. And so the first year, I submitted something entirely done in Scratch. And again, it was unsuccessful. We're beginning to see a pattern here, aren't we? There are two basic principles that I have underlying what I do and the way I do it as a teacher. The first one, anyone can code. And some of you might recognize the picture there. If this was a middle school group of students, I'd probably play a short clip from Ratatouille here at this point. Some of you will have recognized the food critic Anton Ego there from the movie. I like putting cultural references into that. Second principle, anything can be taught through coding. Anything? Here's a little anecdote. Many, many years ago, some of you will notice I do have grey hair. When I was a young, fresh-faced teacher, fresh into school, and I'd learnt all about Logo. I'd read Mindstorms. I was really, really keen. And so my head of mathematics, because I taught mathematics as well as computing. In fact, I class myself more as a lapsed mathematician than a computer scientist. But my head of mathematics said, so what could you teach in the entire mathematics curriculum with Logo? So I went away and thought about it. I went through the entire national curriculum, and I could think of a way of doing every single part of the entire course using coding as an approach. In those days, it was Logo. So I came back to him and said, well, actually, it's the wrong question. It's not a case of what can I teach with Logo. And again, with Scratch, it's not a question of what can you teach with Scratch. It's a question of, well, what would be the best things to teach? What would be the most appropriate way of delivering your curriculum using coding as the hook to get them in and using the curriculum content as the curriculum content as the context for why they code. However, there's two big constraints. In other words, things that cause big problems for me. Constraint number one is the skill level of our students. Now, I'm really, really fortunate. We have a brilliant elementary school, and they do some Scratch in everything from years 3 through to year 6, so it's from grades 2 to 5. So I get 11-year-olds who already have a great deal of knowledge and experience of Scratch. Unfortunately, I teach in an international school. In our part of Europe, I reckon up to 20% of the students in any one year group will be completely different faces the following year. Some of you may teach in similar situations where you have a very transient population. And so we get kids from all around the world coming to us, some of whom have had very, very little experience of IT, others who've had a very similar experience to what we've been doing. And we have to cope with that wide range of experience. Also, there's aptitude and attitude, two very, very different things. Some kids love to sit down in front of computers. Some kids have got a brilliant set of ideas of what they want to achieve. Other children don't. Constraint number 2, and again, to me, this is also a big one. Time. Those of you in the Scratch competitions session earlier on, one of the big issues that came up at the end was the result of a questionnaire, where students were asked, well, how much time did you spend on your Scratch project that you were going to enter for the Irish Scratch competition? And the organisers had up to 20 hours, 20 to 40 hours, over 40 hours, and many of the students saying, 40? You must be joking. I spent hundreds of hours working on this over an entire year. Time is a massive, massive issue for those of us who are working with students trying to produce multimedia. They're going to be ending up doing a lot of stuff at home or a lot of stuff outside of the classroom in order to get everything done to the level of quality that they know they can do. And for many teachers, there's a temptation to say, well, no, I can't spare that time. Look how much stuff I've got to teach in my curriculum. Okay, some solutions. These are what work for me. And again, for some of you, you may find that something else would work for you instead. Number 1, scaffolding templates. Give them a starting point. In many cases, I may start off with something and say, look, here's how I would start doing this particular piece of coding. Take it or leave it. I know most able students will leave it. They already have another idea, in some cases a better idea, of what they want to achieve. But in the same way, when we're teaching children how to write, when we're teaching children about art, we give them a starting point. There's nothing wrong with doing that with coding. Templates. Often if I want to exemplify something, or if I just want them to see what you can achieve, I may give them something where, by altering a few parts of it, they can achieve something much more, and then go away and make further changes on their own. Another one, again, I can't stress the importance of this enough. Give them examples of good and bad. Help them to see why what you think is good actually is good, and help them to see why what you think is bad is really bad. So yes, deliberately build bits of code that don't work in class. Yes? I'll show you some later. Okay, so give them some deliberate examples of code that doesn't work or that doesn't achieve what they want, partly so they can see their error messages. Things like, well, what does happen in Scratch if you try and divide by 0? Anyone know? Now you know what you're going to do when you get home. So give them examples so they can see what could go wrong and what to look out for when they debug their stuff. It'll save you a huge amount of heartache later. And finally, again, another really good one. And again, here I have to say I have a really supportive senior management and really supportive colleagues who teach other subjects. One of the things we've had to address is what do we do about our gifted and talented students? What can we do to help push them further instead of just giving them next year's work? And so was born the idea of the coded option. If you need to do a presentation, and you can think of something that you would like to do using Scratch to do that presentation, if you need to produce an animation to go inside of that presentation, and you want to do a screencast of something you can create in Scratch, if you need to do an investigation in mathematics, and you can think of how you could simulate that in Scratch, or simulate an experiment in science. For our most gifted and able students who can justify why they'd want to use Scratch, we say, yeah, go ahead, do it. Obviously, again, many of them will end up spending a lot of time outside the classroom perfecting it. But certainly the results are worthwhile. So for time, here's a few ideas for you. Number one, for coding projects. Now I use a 5-phase model for design lifecycle. We do problem identification, analysis, design, implementation, and then testing and evaluation. To do absolutely every single bit of coding as a design project from start to finish with all 5 phases, we would find it difficult to do more than a couple of projects a year. In fact, we might find it difficult to do more than one. So, instead, we focus on a specific part of the design life cycle. Again, I'll show you a couple of examples later. Okay, other ICT projects allow for a coding element. Give you a simple example, we use Google Spreadsheets an awful lot. In fact, it was the Google Spreadsheets part that I did which was judged as the national prize winner for U for Energy. But one of the nice things about Google Spreadsheets is you can set up a form for people to answer questions, and you can embed that form on a website. And if you want to, you can embed a piece of Scratch code on that website as well. So they have to solve a puzzle, answer a problem, watch a presentation, try a quiz, do a reactions test, and then fill in the form with what they found out or what their results were, and so on. Another one in terms of time, using Google Sites. I find it useful to help my students organize themselves by setting up a skeleton framework for where they will keep all their work. Again, that might work for you. You might say, no, 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 I can think of better ways of doing that. I know what works for my students. But that's the good side of this. We're here to share examples of good practice and learn from each other. Certainly I've learned a huge number of things over these past 2 days so far. Okay, so this is my curriculum at the moment. And you'll notice there isn't an area that says Scratch in Year 7. But in my communication and modeling unit, if I want to do ebooks made out of Scratch, make an interactive storybook, as well as doing a bit of desktop publishing, a bit of word processing, it's a tool available there for me. If I want to create models using Scratch, and some of these models can be quite sophisticated. Usually, when introducing the idea of using Scratch for modeling, and again, students say, no, no, I'm not getting kids who've got any experience of Scratch. They don't know what the 3 S's are. The stage, the sprites, the scripts. I have to spend my time doing that first. And if that's your case, then yeah, this model won't work for you. But if you're getting kids who already know what a sprite is and can already do a bit of scripting, and you think, hey, I want to include variables, but what would be a good way of doing it? I do simple modeling games. I show them a much more sophisticated one first. I show them the old Hammurabi simulation. Many of you will have seen that on the Scratch website or from the examples. And then we think, well, if we were to write our own simple simulation, what would we do? Website design, and again, we don't just design a website. We take part in collaborative projects like Global Virtual Classroom. And again, if we decide, ooh, we need some interactive Scratch content, they'll write that and then embed it in their web pages. Animation and simulation. I used to teach this just using PowerPoint. But nowadays, I can show them why Scratch is a much better tool for doing this sort of work. So yes, we do an aquarium, but I like to have a better context. So we look at control technology, and we say, well, since we know what variables are, we can have a variable for the temperature of the fish, and a variable for, the temperature of the water, and a variable for how much oxygen there is in the water. And I better move on quickly. Year 8, my grade 7 students, data and applications. And again, one of the questions that I often ask them at this stage is, well, what does your Office software not do that you would like it to do? And I get some great answers. I had one student once say, I want to do a voice-activated presentation so that when I want the next slide, instead of having to press something, I just say, next, and it goes to the next slide. It took us about 5 seconds to code a voice-activated slideshow program. And again, for some of you, that might be the sort of thing you want to explore and experiment with. We then built on that later on. We were looking at representing data using a spreadsheet and the different tools available in the charting wizard. And I said, well, there are some diagrams you can't do with Excel, though, aren't there? And one of my students says, but you could write a script in Scratch to do it. And so again, shortly after, we ended up with a little application that allowed them to make pictograms, little charts. So you can say, well, I want to have 7 little people there. And so draw 7, and then 4 in a different color, and then 5, and then 3. You could put in different numbers, and you could change the sprites. So instead of little men, you could draw little cars or little boats. And again, this came from one student saying, we could use Scratch. My Office software won't do this, but that's not going to stop me. So web development, we go a little bit further. And again, we often integrate Scratch content with what we do when we're developing entire websites and not just building individual pages. And then educational game design, yes, we use Scratch. This is where I formally deliver what the life cycle is. But again, we don't have time to deliver the whole life cycle. So we focus largely at that stage on the design part. Later on, we'll do another project and we'll focus mainly on analysis. Another time we'll do another project, we'll focus mainly on testing. So they'll get the whole experience of what the design life cycle is about, but they'll do it in different projects. Okay, my year 9s. Again, I may get 20% completely different students. And so I do something where I can make sure that they can still remember how to communicate, how to model. And part of it, yes, I give them an example of some scripting to do with making your own simulation of a theme park. Similar to theme park, so roller coaster tycoon or theme park tycoon type games. And they make their own game. Some of the students, because they're totally new to it, they'll spend a lot of time developing their own sprites. They'll work largely with code that I give them as a template. They'll have a working game at the end of it, though. Other students will say, no, 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 no. I can think of something much better. I want to include some artificial intelligence and have little people moving around from one attraction to another. And so they do. E-commerce. So again, we're back to developing websites. Hopefully you can see the theme here. And with the e-commerce one, again, often we'll create some viral games that they can use in Scratch. One of them was featured on the Scratch front page, and my kids were really, really excited because, wow, they had over 1,000 people visiting their game and leaving comments about it. That's what worked for me. As I said, you may find something else would work for you. And then finally, Scratch and Control. This is where we do a little bit of work with Arduino. Some of you may have noticed I've got an Arduino down at the front here. We do a little bit of work with Makey-Makeys. We play around, we experiment, and we come up with ideas for control technology projects. And I try and encourage them to reuse and recycle wherever possible with this. So if you've got a broken toy with a motor that still works, well, you could always take the motor out. And again, for some students, if that side of things is too much, they could always make a simulation of what they would like to design. From the age of 14 onwards, that's not the end of their experience with Scratch, though. One of the things I try and promote in my classes is that Scratch is a rapid prototyping tool. If I'm teaching a class doing IB computer science and we're doing recursion, we might use Build Your Own Blocks or Scratch 2.0 to look at examples of recursive blocks first, get an idea of what recursion is about before we then turn our hands to typing the code. So we'll use it as a simple way of developing applications to teach much more complex sets of skills. If you were in Dan Garcia's session earlier on when he was talking about how you can use Snap and build your own blocks to create your own data structures, again, I do that with my IB students. We look at how we can create things like stacks and queues and all the different functions you use to manipulate them using build your own blocks. So they get a feel for what you need to do to create these alternative data structures before we then look at doing it in another language. And then we also try to encourage Scratch as a multimedia tool. Just as a show of hands, how many of you have assemblies in school where students might use Scratch to do a presentation so they can then interact with what's on the screen? Again, for some of you might say, yeah, that's something I'd like to exploit and do with them. But we use Scratch for a wide range of different uses that perhaps some of you may find useful. When doing control technology, if we decide we need to print out a net for something to be cut out of card, sometimes it's far easier to create the net in Scratch first, print it out, and then cut out what you're doing in card. So again, think about other ways that you could use Scratch within the different types of things you do within school. I'm going to rush through a couple of things here, just to give you an idea, because I know that we started a couple of minutes late. It's coming up to 1:30. Okay, so first of all, some Scratch challenges. This is one of the things that I do to build up the profile of Scratch. And so I issue a monthly coding challenge, and just to show off, take an Arduino Leonardo, plugged it in here, and if I just turn this just a little to the right, oh look, it makes that a little bit bigger, just me showing off here. Let's also switch a little red light on to tell me that I've done that. If I turn it a little bit further to the right, oh, there's my other Scratch challenge. And again, there's no reason why you shouldn't be saying to the kids, hey, mess around with this stuff. What can you do? Now obviously this looks really weak and wimpy and tiddly because it's just that little blue knob there and a potentiometer. There's no reason why a student couldn't create a cardboard housing for that get a large bottle top, hot glue gun the bottle top on there, and suddenly you've got a device that looks fantastic, that has flashing LEDs and a knob to turn, and all it is just one of these boards that plugs into Scratch. And so I like to try and get the kids excited about the stuff and see the potential of what they can create. And again, if you want some copies of my ICT challenges, I'm more than happy to share them. But don't just use them, because I find that the student-inspired projects, the ones they come up with, are the ones that work best. When a student says to me, can you think of a way that you could create a program to do different sorts of art projects? So, well, that can become our Scratch challenge for next month. We turned the idea of creating a graph or chart making program into one of our Scratch challenges. It was one of our most successful ones. And again, we had some fantastic ideas from students about different things that they would do to create different types of diagrams, all done in Scratch. Again, throw in an incentive. It doesn't have to be something massive. If you do things like house points in schools or merits, have a word with the person in charge of the pastoral side of the school and say, I want to give house points or merits for these. If your school doesn't have a healthy eating policy, chocolate bars work well. Cheap technology. One of the things way back in the days of floppy disks, I used to find that floppy disks with Mr. Men on worked brilliantly with 17 and 18-year-olds. Also stickers, again, with 17 and 18-year-olds. But try and big it up, make it important. Give them certificates to say, yes, you took part in this challenge, and give them out in a school assembly. Make it seem like it's, hey, it's not just the people who do sporting activities who get awards. It's also the geeks. Finally, I'm going to finish with my robotics club. What's the purpose of the robotics club? I'd say get them involved in the wider community. So one of the things that we did earlier on this year, we took some of our robots that we'd built and a couple of examples of makey dance mats and various other bits and pieces, including a set of aluminium wind chimes for a pico board. Nice, simple idea. You just get your kitchen foil in strips, connect them to a pico board or a makey, and when the children blow on them, you can have whatever sounds you want made with them. The dance mats worked extremely well as well. We did a very simple sequencing exercise for the kids so that they could press the sheep, the pig, the horse, or the jungle dance mat. We had 2 jungle dance mats as well to have different animals, and so if they wanted to have sheep, horse, pig, sheep, horse, pig, they could do that. Remember, this is our 17-year-olds showing off to our 3 and 4-year-olds, this is what you can do when you get bigger. You can make stuff like this. So they're really excited by that. But I wouldn't stop there. Get your students involved in outside events and challenges. This summer we did our Scratch Day event. We called it Scratch and Control, and we invited people from wherever to come and see what our students were doing. And again, we had some students turning up to experiment, play, and show off and say, look, this is what we can do. Next May, we're going to do digital storytelling. Our older students will create digital stories to then show off to the younger students. We're going to run Scratch and Control again at the end of November. And again, if you want to know more, I'll be happy to give you a bit more information. But unfortunately, that's taken me a little bit longer, and I really need to stop so that you can take yours. So if you do have any questions, I'll hang around after yours, and then I can go over and show you some examples and other things. Thank you very much.
Good evening. My name is Juan Carlos López Garzón, like the famous Spanish judge, former judge. I apologize for my limited English. I'm going to help myself reading the communication sometimes, or maybe every time. And I slept only a few minutes last night, so please be patient with me. So, engage. I come from Zaragoza, in the community of Aragon, Spain. Is near Catalonia. Sadly, we have got beaches, but it's Aragon, not Oregon, USA, not Aragon, Spain. Is a data very important. 7 years ago, the Aragonese Association of High Abilities, also known as No Limits, began conducting extracurricular workshops about introduction to robotics for her partners, children and young people from 8 to 14. Workshops were based on Lego Mindstorms kits. The following year, we introduced a Lego We Do system for children from kinder to 7. Since 2008, we organize technology campuses for children and teenagers, exclusive for students with high abilities, being pioneers in this area in Aragon, I think. The activities of our association have been a showcase for elementary and middle school teachers, incorporating robotics into the basic curriculum gradually, like the main goal. This mission shall be sampled in regard to robotics and the core regular curriculum, even in Aragon. The change of inclusion in the elementary subject called knowledge of environment is an union of science and social studies, is very high in a certain requirement block called Objects, Machines, and Technologies. In the middle schools, robotics has a place in the technology subject. However, while in the middle school it's easy to find robotics in regular curriculum in the elementary school, teachers still cling to the textbook, and it's very difficult to find practical experiences like that developed in association workshops. There are several reasons for this: ignorance of the subject, comfort, lack of material resources, fear of new things. The best way to solve this problem is to bring robotics teachers. They can see in their own center, in their own school, how robotics can be worked with children in the regular classroom. Anyway, the first step that has been given to reach this goal has been to suggest to the school parent associations organizing extracurricular activities using their own school facilities, computer classroom, capacity development classroom, and so on, approved by the school board, of course. Do you know capacity development classroom? It's an experience born in Aragon to meet above the average students in ordinary schools. I think it's a great commitment for diversity. An example is elementary school Calixto Ariño from Zaragoza. Since 2009, I'm conducting 2 workshops on introduction to robotics. One of them is based on we do for kids from 5 to 7, and the other is based on milestones for children from 8 to 11. In the same way, extracurricular activities has been programmed in other public schools. The association has also collaborated on workshops in several Aragonese public schools, joined in an official program called Knowledge Deeping, supported by Spanish Ministry of Education. The first experience reached the Zaragoza City of Knowledge Foundation, which together with Ibercaja Bank Social Department and the Association of High Abilities pushed for extending the idea to other public schools. And thus, during the past year, a program was developed involved 3 centers of Zaragoza City: Calixto Ariño, Parque Goya Park, and John the 23rd. And this is a summary of what the experience has meant. I showed you a video posted on YouTube. Just a moment, please. Okay. The original song is in Spanish, but is subtitled in English.
Pues el proyecto Robótica en la Escuela nace de la decisión de la Fundación Zaragoza del Conocimiento Ibercaja de ofrecer actividades de robótica a los escolares. Entonces se pusieron en contacto con nosotros para que realizásemos la programación y dotásemos de monitores y contenido de actividades. También hemos hecho sesiones en Centrum para clases enteras, más como toma de contacto con la robótica.
Está demostrado que la robótica, sobre todo en edades tan tempranas, y quizás hemos sido como proyecto piloto innovador en esa vía, ayuda a desarrollar otro tipo de capacidades que complementan todo lo que hacen habitualmente en el aula.
Planificamos los talleres para que los niños monten robots y luego aprendan a programarlos. Programar no es más que poner en orden las ideas que tenemos sobre lo que queremos que haga el robot. Entonces la programación básicamente es pensamiento lógico, muchas matemáticas e intentar que los niños estructuren lo que tienen que ir haciendo. Y cuando ya vemos que han cogido un poco de soltura, pasan a desarrollar Scratch. Porque el Scratch tiene la ventaja de que es un software gratuito que se puede descargar los chicos en casa. Y es un programa que también pues, potencia mucho el razonamiento lógico, hace que los niños tengan que pensar las acciones, secuenciarlas, y es lo que más les cuesta a veces a ellos, ¿no?
La verdad es que estoy muy contento. Es una actividad bastante original, me parece bastante innovadora. A los chavales les suele gustar mucho, eso siempre es gratificante, ¿no? Estar haciendo algo que a los chicos también les guste. Y me parece que tiene bastantes aportaciones en el sentido pedagógico, que tiene mucho que ver con los contenidos y las competencias que se desarrollan en la etapa de primaria, porque necesariamente para programar los chavales tienen que manejar un poquito de matemáticas, un poquito de coordenadas, un poquito de operaciones, un poquito de variables. La actividad a mí me parece que ese punto de motivación, que es algo bastante difícil de conseguir muchas veces, la actividad lo proporciona. Entonces, a mí en ese sentido me parece bastante interesante.
En la Fundación hemos trabajado siempre en el apoyo a todo lo que sea la cultura de la innovación y el emprendimiento de base tecnológica, ¿no? Creemos que estamos ya en una sociedad tecnológica, en la sociedad del conocimiento, y consideramos que al final son unas habilidades básicas para que alguien que tenga para poder desarrollarse en su vida diaria. Que los robots tomen las aulas es una excusa para que aprendan una serie de capacidades. Al final es una pequeña semilla que plantamos por diferentes centros y que queremos seguir evolucionando.
In this project, students work with Lego Widow kits using the school computer room. They begin assembling some pre-designed models, and then they make an introduction to Scratch and try to control their own creations with their programs. They think, they build, they make, they learn by doing. Well, for the next year, there will be a school, Parque Goya Park, which has pledged to introduce into the regular curriculum knowledge of environment subject, the tasks of introduction to robotics with Lego Widow and Scratch software. They will meet the following Spanish curricular requirements: basic competence, like this, knowledge and interaction with physical world, data processing and digital competence, social and civic competence, and autonomy and personal initiative. And evaluation criteria, like this, assembly and disassembly of sample objects, observation, and analysis of the operation of objects and machines, and so on. I hope that the experience will spread, and gradually, when teachers lose their fear of introducing practical tasks in their classrooms, we realize that the way to develop skills and competence is just learning by doing and not by means of test for assess memory. Thank you very much. questions? No? Thanks, you are very kind.